Good afternoon, everybody. Thank you so much for coming to join this session. Welcome to the session Responsible Human-Machine Teaming Along the AI Lifecycle, an interactive scenario. So it's great to see so many of you here. My name is Ingvild Bode. I'm a professor at the Center for War Studies at the University of Southern Denmark. And there I also lead two different projects funded by the European Research Council. You will find flyers of the projects in the room. And both of these projects really study how practices of using AI in weapon systems in the military domain more broadly change international norms. And the discussion that we will have today actually feeds into one of these projects, the Auto Practices project, that seeks to strengthen human agency in the context of human-machine interaction. I've co-organized this session together with Lynn Piaskowski from Johns Hopkins Applied Physics Lab. And I should add that all of the speakers who will be speaking at the second part of the session will speak in their individual capacities rather than for their organizations. The lifecycle framework that structures this session, so we will use a scenario in the session that goes through a lifecycle framework. And that framework was actually part of an effort or co-developed by the IEEE research group on issues of AI and autonomy in defense systems. So this group has met over the last 2.5 years, bringing together a diverse set of experts to develop a framework, really, to help inform a range of stakeholders involved in various types of decision-making related to autonomous and intelligent systems across the life cycle. The document outlining this framework will be published very shortly, hopefully. This session is structured into 2 parts, right? So the first half an hour will be an interactive scenario that takes you through various human-machine interaction challenges across the AI lifecycle, and so this is just a representation of the lifecycle, right? And then we move on to the second part of the session, which will be an expert panel discussion that will unpack some of the choices that you made in the first part, right? So the pressure is on for you. For this scenario, we only focus on 5 particular stages of the life cycle, because we can't, unfortunately, take you through the entirety of it. So we'll focus at actually most of the early stages. We look at the stage before the development of these systems. We look at R&D, TEVV, considering the human, and then we look at post-use, finally. And we start from the following basic storyline. Researchers working with the military develop an uncrewed underwater vehicle swarm that can be used for intelligence, surveillance, and reconnaissance. This is our basic premise, right? And you will be basically pretending to be that group of researchers across different stages of the life cycle. You will make your choices using a Mentimeter. So this is, please just either scan this QR code or enter this code on your phones, because now I will hand over to my colleague Ariel Kohn, who will competently lead you through the scenario. And she will tell you exactly what to do. Of course, all the choice is yours, but you will have to choose between different options at different stages of the life cycle. And so I hope you enjoy this. Let me see if this is the right slide. Yes, it is. There's also, if the code doesn't work right, you just can enter that number when you go to menti.com on your respective browsers. Are we all confident?
If you want to give it another minute, I can start.
Okay.
I can start chatting before we get to the.
Let's do that.
Okay. All right. Well, thank you, Ingvild. I was part of the research group that she just mentioned. And one of the things that we found working through the scenario was that in order to address many of the concerns and issues that we're talking about today and at this event and throughout many other discussions, as we're looking at the use of autonomy and AI in weapon systems, we found that one of the really important things we need to do is start looking at these issues much earlier in the life cycle stage. So as Ingvild mentioned, although there are 9 stages to the life cycle, we are focusing on the earlier stages because that's when a lot of the really important decisions get made. The other thing that I want to mention before we get started is that although the life cycle had 9 stages, well, in addition to the 9 stages that the life cycle had, we also created or identified 5 activities that we believe must be ongoing throughout the entire life cycle of a system. And those are 1, excuse me, evaluation of legal, ethical, and policy concerns. 2, responsibility, accountability, and knowledge transfers. 3, considering the human. 4, TEVV, monitoring, maintenance, and system updates and interoperability. And 5, risk assessments. So as we go through our scenario stages here, we're assuming that all 5 of those activities are occurring at and between these stages. So I think we can go ahead and get started. So we're starting with stage 1, which is before development takes place. Now in our, excuse me, in our full life cycle, we actually have 2 parts to this stage. Part A is these very big general considerations, the kind of issues that we're dealing with now. The questions around what's legal, how to address technical issues, what political solutions do we need to be considering. And so events like GC REAIM, events like this session fall into the category of Part A for that stage. Part B of stage 1 is the considerations that need to take place before an individual system is developed. So these are going to be more of the technical questions, the questions about who specifically might be involved in later stages, things like that. And for our scenario today, we are going to be looking at Part B. Part B before the development. So our storyline begins. As geopolitical tensions rise, military leadership proposes developing new software that can help a UUV swarm send more information to operators to enable operators to make more informed decisions about potential targets. The UUV swarm will include AI-based decision-making specifically for tracking, target identification, and classification, which can assist in potential engagement decisions. This choice raises questions about the role of these operators in the decision-making process. So we now ask that you choose between 2 options. For choice A, the UUV swarm feeds real-time data to human operators, but the UUVs decide which data is sent and prioritized on the operator's interfaces. The UUV swarm is empowered to make more decisions. For choice B, the UUV always sends all information to the operator. Due to network bandwidth limitations, sending this much data can result in latencies. And in this case, the UUV swarm is empowered to make fewer decisions. So we'll go ahead and give you a couple minutes to choose what you prefer.
You can't choose.
Oh, no.
Well, that's not good.
We did run a test and it worked.
Oh. I'm so sorry. I didn't need to do anything else last time.
Did you
Yeah,
advance
sorry.
the slide?
The next slide, we can vote on the next slide.
Ah, oh. Okay, hang on. There's always a technical glitch.
Yay. No. I'm sensing a bias. Does anyone else need more time, or are we ready to? Okay, not yet. Oh, some people are still connecting. So don't move the slides forward. For people who are done, I'll give you a clue as to what our next question is going to be, and you can think about it for a moment. We're doing an open question, and we're asking what are the factors that were most important for the trade-offs that you were considering, and this is just going to be a 2 to 3 word answer for a word cloud. So if you want to start thinking about what the key words are for the decisions that affected this. Does anyone else still need more time? Okay, go ahead. And please do answer, like as Ingvild said, this will influence future research. 31 responses. Okay. I think that seems like that's pretty similar. So speed was an issue. Someone had put priorities in here, and as it spun, I saw pirates initially. Can people in the back read this, or is it getting too small? Okay. Yeah. Actually, yeah. If you guys are interested in seeing what some of these results are, maybe give us your email address, or just come up afterwards, and we'll share the results as we get it recorded. Does anyone else need more time? I think we can move on. Okay, so we now proceed to stage 2, which is research and development. And this is the same as in the life cycle, the full life cycle. In this stage, people who have been identified as responsible and accountable for everything that's happening here will, obviously they'll be responsible for designing the system, making sure it meets, whatever specifications have been asked. And they'll also want to identify and address any concerns that arise during system design. You'll want to start looking at assurance and testing and evaluation at this point. And then you also want to start making sure you've considered the human, including how the end user will operate and interact with the system. And so in our storyline at the R&D stage, the researchers decide to follow a system of documenting and assuring human responsibility throughout the life cycle. They decide upon a choice between 2 options for realizing this. And so we were giving you guys these 2 choices. Choice A, the researchers develop a rigorous system of documenting responsibility and accountability, clearly defining roles and decision-making authority for all members of the development team, as well as the operators and the UUVs once the swarm is live. All design choices, test results, and operational decisions are clearly documented and attributed. At crucial handover points, the system integrates accountability checkpoints requiring sign-offs by key stakeholders. This choice slows down the development process significantly. For choice B, The researchers develop a flexible documentation strategy that prioritizes high-level decision-making processes of the project. This system does not prioritize comprehensive detail, but allows individual team leaders in the development process to determine the level of documentation required for the processes related to their specific area of responsibility. This choice includes periodic reviews and results in more rapid process for system design and development. And, okay. Much closer. I don't remember how many people were in the first one. Yeah. Does anyone need more time? All right, are we ready to, I think we can move ahead. And this time there's no extra questions. Okay, so now we're moving on to stage 3. Now in the full life cycle, stage 3 is actually procurement and acquisition. We're skipping that for the purposes of our scenario today. And instead we're skipping to test, evaluation, verification, and validation, and commonly referred to as TEVV. So in this stage, various procedures are performed to ensure that the system will behave as intended. We want to make sure that the system meets expectations. I will also flag that this is one of the stages that we also designated as an activity that must occur throughout the entire life cycle. So it is both an individual stage and something that needs to happen recurringly. For the purposes of our storyline, the UUV swarm is now available in prototype form and it goes through TEVV. To determine an acceptable error or uncertainty rate for the swarm to exhibit regarding object tracking and identification or classification, researchers develop a computer model that can simulate the UUV swarm's operations by running the simulations thousands of times with different inputs driving these error and uncertainty rates. The model also assesses how the UUV will interact with human operators across various context-diverse scenarios, thereby assessing their impact on mission success and identifying potential failures resulting from their use. Researchers get feedback on these results from a panel of experts, including military strategists, roboticists, ethicists, and legal advisors. The system is designed such that if one of the UUVs comes across an object it cannot identify, it notifies the operator for guidance on how to proceed. Thereafter, the researchers choose between 2 options. So we have choice A. If the operator recognizes the object and it is not a threat, the operator can update the swarm logic to recognize this object as a non-threat in all situations moving forward, and thus the UUVs will no longer check with the operator regarding this object. This will cause or allow error and uncertainty rates of the swarm to change in real time during operations. For choice B, although the operator can use the interface to log this specific object as one that is non-threatening, the operator cannot update the swarm logic in real time. Instead, the systems must go through a TEVV cycle to model logic changes, and all error and uncertainty rates remain static during real-time operations. Does anyone else need more time? Okay, only a slight bias here. All right, so now we will move on to stage 4, considering the human, education, training, and human system integration. Again, this would be stage 5 in the full life cycle. And as with TEVV, this is the only other component that we identified as both deserving of its own stage and something that needs to happen throughout the entire life cycle. So yeah, it can be very easy to focus on the technology, but it's really important to remember that humans are the ones who are creating the systems, humans are the ones who are testing the systems, humans are the ones that are ordering the systems to be used, humans are operating it in some fashion, humans are reviewing the system, and all of this is the case regardless of how autonomous the system is. And so we need humans to be able to understand the technology, they need to be trained how to use it, they need to understand its capabilities and limitations, and we need to ensure that we always know who's clearly responsible and accountable for the system throughout the entire life cycle. And then, of course, for this particular scenario, and in general as well, we wanted to focus on the human-machine teaming component. So for our storyline, as the UUV swarm prototype is drawing closer to potential deployment, researchers consider different choices for designing its user interface. And this time we're giving you 3 options, and we ask that you just choose one again. So choice A, only high-level information is provided to the user interface with no way for operators to access more detailed or lower-level information. This is to streamline the user interface and prevent overload or confusion for the operators. For choice B, information is provided at varying levels. The default user interface provides high-level information only, but an operator can drill down into all the information gathered by the UUVs if they so desire. The user interface cannot be customized and is always the same regardless of operator or scenario. For choice C, the user interface is dynamic. At times, it presents only high-level information to the operator. At other times, it provides detailed information depending on whether it believes the operator may need that information to make a decision or whether that information is particularly important. So we'll give you guys another minute to answer that. No one likes poor option 1. Oh. Does anyone need any more time? All right. So now we've walked you through most of the scenario. We're now going to pass this over to our panel members, which is led by Anna Nadia Baidza. And among other things, the panel will consider the post-use stage of the life cycle, which would be stage 9, the final stage in the full life cycle, but here it's stage 5. And our panelists will talk about some of their perspectives on this scenario and other stages. And we have one final activity for you as they come up here. So yes, as you were going through the whole scenario, again, just sort of keywords for a word cloud, what were some of the issues that influenced how you were making the choices you were making? And we'll give the panelists a chance to fill out their preferences too, if they want. But if you are a panelist, once you've finished, please feel free to come up. Oh, okay. Oh.
Thank you. Right. Oh, wow, okay, lots of keywords. So let us now move on to the second part of our panel. This is a roundtable discussion during which we will unpack some of the choices that you, our audience, have made during the scenario together with our experts. So my name is Anna Nadibaidze. I'm a researcher for the AutoNorms and AutoPractices projects at the University of Southern Denmark, and I'm the moderator. And today we have with us, starting from over there, Dr. Nehal Bhutta, Professor of International Law at the University of Edinburgh and Commissioner for the Global Commission on REAIM. Shimona Mohan, Associate Researcher at the UN Institute for Disarmament Research. Lynn Piauskowski, Supervisor of the Human Machine Engineering Group within the Air Missile Defense Sector at Johns Hopkins University Applied Physics Laboratory. We have Dr. Tom Watts, Leverhulme Trust Early Career Research Fellow at Royal Holloway, University of London. Last but not least, Jack Shanahan, Lieutenant General retired from the US Air Force and member of the IEEE Research Group on Issues of AI and Autonomy for Defense Systems. So let us now start from the end and discuss potential options that could have happened. May we get the... Yes, thank you so much. Could have happened. So imagine that a military has decided to deploy this UUV swarm that we've been talking about this afternoon to fulfill its intended ISR objectives. But the area of deployment is proximate to a maritime trade route, so civilian ships may also be present. And we have 4 options that I would like you to consider that could have happened while using this swarm. So first of all, the system does what it's supposed to do, and perhaps due to luck, the environment was exactly like what happened during training. Second, the system misses something important and we are attacked. Third, the system mistakes a civilian ship for a military target, and a human decision results in attacking a civilian ship. And fourth, the system is too slow or too ineffective for it to be used and is retired. So I'd like to ask, first of all, our experts, which one of these options do you consider most likely to happen, considering the choices that we made today? And what would be the implications of this scenario, from your perspective and your area of expertise?
Okay, I'll start. I'm going to say that I cannot answer the question as definitively as it was framed, so allow me to offer a 5th option based on my military experience and say the answer is it depends. And let me say why it depends. How the system operates once it's fielded depends on 2 equally important considerations. First, how the system is trained and tested, not only the AI models, but also the AI model that's integrated into the UUV. The amount, the type, and the quantity of training data is critical to system performance once it's fielded. As I can attest from my experience with the project called Project Maven and also the DoD Joint AI Center, or the JAIC, you must spend an inordinate amount of time collecting enough operationally represented training data. We also spend a great deal of time doing test and evaluation, what I would call rigorous and disciplined test and evaluation. And in this scenario, T&E is a little bit more complicated because of that need to test the AI model, the UUV, and then the integration of the AI and the UUV. And then second, as we say in English, context is everything. However successful the training and testing processes might have been, until that system is fielded, it is impossible to duplicate perfectly the operational environment. Things will invariably go wrong. For that reason, it is extremely important to have dedicated training, education, and testing plans. Training should include academics, simulators, experiments, smaller scale events, leading eventually to larger scale exercises in which the full capability of the UUV swarm can be assessed and then modified as necessary before it is operationally deployed. And throughout the development, testing, training, and the red teaming processes, it is incumbent on everybody involved to assess the failure modes, expected failure modes, maybe some unanticipated failure modes, boundary conditions, and the potential for and ways to mitigate the effects of adversarial attacks. And this should include the end users, not just the designers, not just the developers, not just the testers, but the end users. And of course, if the system fails, there has to be a reset period to fix any of those problems and, as necessary, to retrain the AI models. And depending on the type of failure, as we heard in, I think, the plenary session this morning, a tactical failure could end up having strategic consequences. And not only senior military leaders, but also policy officials must be aware of these possibilities. And I would say today, most policy officials probably would not be aware of system failure modes. So in the end of all of it, my answer is, I don't know, it depends. I'm not going to pick one of the four. Thank you.
Anyone dare to pick one of the four?
I won't pick one, but I'll pick one to eliminate. I think given our audience's tendency to take some of the riskier choices, which I actually don't, I'm not opposed to, I think number 4 is unlikely. I don't think that the swarm will necessarily be too slow if we're actually employing things like dynamic T&E evaluation, we call it battlefield learning, when the actual autonomous system can change its internal algorithms and error rates during real world operations. So that choice, along with some of the agility that was built into the process, some of the real-time, some of the ability of the UUV to make more decisions. You guys chose that one as well, very handily, actually, that option one. So I think you went for speed, you went for a little bit riskier, so I think number 4 is less likely. Hopefully 2 and 3 don't happen. Hopefully number 1 happens, but I think that any combination of those could occur.
I mean, just to jump in on those points, what I find very interesting about this entire exercise is the role of uncertainty and how that presents an opportunity for us all to reflect not just on what our respective expertise is, but the ways in which we're all social creatures and would have had our understandings of this scenario shaped by that. So as Clausewitz argued, of course, friction is an inherent part of war, and it's very difficult to know and project what will happen and what the adversary would do. For example, in the specific scenario, who isn't to say the adversary puts their warships within the maritime traffic area to create greater clutter through which to kind of confuse and slow the warfighting process. And I think these social dynamics are really useful to reflect on, right? Because in the same way we speak about operators having automation bias, I think sometimes in these debates we can have expertise bias, where we tend to listen to those who speak the same language as us and work in the same fields. And one of the major contributions made by this panel and the broader REAIM process, of course, is to bring us all into greater dialogue and encourage us to reflect on what we've come to think about is appropriate and the role of uncertainty in potentially shaping and influencing our response to this scenario. And I think one broader point that's worth reflecting on is the way in which essentially, as I said, this plays out in real time, and the role of uncertainty in creating a space for us all to perhaps project in a variety of different ways. Thank you.
Thank you. I think when I was presented with this, I took the 10-80-10 route, which is the first option would be the 10 that we hope would always happen. Everything happens as planned. Everything is perfect. All is good. The last 10 is something we hope would never happen, that the system is so bad that we spent all that money, time, effort, everything, but then we have to retire it, which is also a very rare case. The middle 2 and 3, I think, are the most likely things to happen throughout the entire course of the of this system being used, and this bunch between the 2 and 3 sort of brings me back to the Petrov incident back in 1983, where there was a false alarm through an early warning system in the Russian forces. And the idea there was sort of a human there to make sure that this was looked at from a human perspective after the machine had already analyzed all the data that was present, which is why there was no ICBM retaliation on that end. And later on, when there were these audits being done about what went wrong within that early warning system, it was found out that the error was due to a very highly integrated sun ray on a high density cloud, and that was what was perceived as an ICBM attack from the other side of the world. So these are sort of very intricate, rare scenarios that might occur, which in the battlefield might mess up everything that you've planned already, everything that you've tested, everything that you think will go right. Which is why I think the 2 and 3 options are the ones which are most likely in this scenario. Even if everything is going well, there might be things that are missed, there might be things that are misinterpreted, which is why you always need a human there to make sure that you're seeing what the machine is seeing as well.
So I could be a lawyer and say, well, it depends. But I'm going to be a lawyer in another way, which is rather than think about which of these is more likely, is ask which of these, if they happened, would for me be have interesting legal consequences. Number 1, none. Number 2 would not have legal consequences under the laws of war, but it could have significant legal and command consequences in terms of the people responsible for fielding the system, for operating it. A mistake or an error like that would certainly have to be reviewed and could result in disciplinary consequences. And an interesting question is, how would you, if the mistake happened and it had negative consequences for your forces, how would you ensure that the right people were held accountable for that? Right? Scapegoating the wrong people is a problem in that scenario. If you held the wrong people responsible, or you held an operator responsible where in some sense it was design flaw, that's something that I think people should think about, what the consequences has for military discipline. Third, could have legal implications. It depends on, so a mistake is an interesting legal category, right? There's no liability for mistakes per se in the laws of war. But if you keep making the same mistake over and over, it gets to the point at which, at least under international criminal law, it seems you seem to be indifferent to your obligations, which could result in criminal law liability. But if the mistake happens not just once, but simultaneously across 10 ships in the same sea lane, which is the risk that comes with scalability, that in itself could be a grave violation of the laws of war. And 4 is sort of legally indifferent, I think, in consequences.
Could I just do a two-finger on something you said here, which I think is so important? And I'm going to do this to show my bias in favor of this Lifecycle report when it finally gets published on the website. The idea of accountability and responsibility, there's often a tendency when talking about responsibility and accountability for AI-enabled systems to say, well, the military is not going to hold people accountable. The machine, the software developer, that's what I would call laundering of accountability and responsibility. Throughout this life cycle report, accountability and responsibility was taken into account at every step of the way, with the final answer being somebody has to be held responsible and accountable. Generally, as somebody with a military background, I raise my hand and say, hold me accountable. I don't think everybody believes that, but I think to see the report and see where the accountability and responsibility is discussed, I think will be very helpful for people to get away from that sort of stark 1 or 0. Nobody's held accountable, or the wrong person or wrong people are held accountable. So I think that's a very strong point. Thanks.
Thank you so much for that. So now we're gonna go back a little bit to before developing our UUV swarm and contextualize the choices that our audience made from a different perspective. So we already heard from legal, operational, but also strategic, ethical, and other perspectives that are represented in our roundtable. So at stage 1, I don't know if you remember or you forgot already, but the audience chose the option A, right, where the UUV is empowered to make more decisions. Yes. The UUV decide which data is prioritized and sent to the human operator. So it was a clear choice for this one. And at this stage, before development, there are important trade-offs to consider. And this is a stage that might not get as much attention as other stages of the life cycle. So this is what I really wanted to pause on that one and ask our panel experts to briefly comment on these trade-offs from each of their perspectives and areas of expertise. So starting with Lynn.
Sure. So I was actually fascinated at how this one didn't sort of garner more 50-50 response and everyone was fully into the more automated kind of approach. What I'll comment on is that at this stage, even at this stage, and I know Ariel pointed this out, we need to be thinking about the human and the end user. And so I was glad to kind of see that here. There are frameworks that we use sometimes. This sort of is reflective of a MABA kind of approach. If you've heard machines are best at, men are best at, which is really not how we need to think about these things. It's a very sort of prescriptive, static way. We need to be thinking about dynamically over time how a human, an individual human, and how an individual machine can interact. And that's a very difficult thing to do. It's very heavily context dependent and all of those things. So instead of actually making a decision at this stage, I would cheat. And I would say fundamentally what we need to do regardless of decision is get the end users involved all the way back at this early process and getting them ingrained. One quick sort of C story. So I was working on an EW system and we were trying to design the user interface and figure out some of these hot, like early decisions about what we do with the system. And we had some engineers go out onto a ship and they said, well, you know, on this prototype, the users didn't know what they were doing, and they were trying to execute this task, and they were using the wrong screen to do it. And I said, okay, well, when you asked them why, what did they say? And they kind of looked at me with blank eyes, and they were like, well, we think they didn't do the training. And I was like, no, when you asked them why they're doing what they're doing and what their thought process is, what did they say? And they said, well, we didn't ask. And so fundamentally, that's the key, right? Ask the end users, get them involved, even at these early stages, all the way through. So even if they, and that doesn't mean doing everything they want, it just means that they understand the decisions that are made from the beginning, right? And that's really critical.
Jack?
I was surprised by the results, I'll be honest with you, which I'd love to go to war with the people in this audience because you seem to be a little bit more, have a little bit more leeway on this. But I'm going to give the same answer I gave earlier, and this is very context dependent. And let me talk about that. So I would say there is a very big difference between operating in a peacetime environment, a crisis developing environment, and a wartime environment that, let's just say, for the sake of argument, is between two peer competitors. So whenever I hear the word trade-offs, I immediately think about risks. What are the acceptable levels of risk? So in peacetime, or maybe even in a sort of developing crisis, generally I would expect lower tolerance. So I would have thought in that case, choice B would be the better option. But some of you may have made this leap of faith and assumption about what are we really talking about, what kind of crisis. So in high-end combat, I would fully expect states would be willing to accept more risks. And it's reasonable to me to believe that policy officials and military leaders will be willing to devolve decision-making to lower and lower levels. And in fact, they may not have a choice because the speed at which combat is unfolding and human saturation. So in that case, I would expect choice A to be the better option. Optimally, and I'll say optimally, you would want to design the UUVs in such a modular way that you could tailor the software based on different operational contexts and different levels of acceptable risk tolerance, choosing, for example, between acceptable false positive and false negative rates based on the scenario as it's unfolding. That is very easy to say, is extraordinarily difficult to do, at least with a given state of technology. In the United States, I would say in that scenario, since we really can't build all that in from the beginning, I would expect us to rely on a combination of 3 different types of controls to kind of get to the best answer. First of all, technical controls. What do I mean by technical controls? Hardware and software controls, most of which you would want to build in from the beginning in the design and development phase, but some, to be honest, you might have to add in later based on feedback from the operational context. Second would be policy controls. You don't necessarily build policy controls in from the beginning, but you will give policy guidelines during the design and development, but much more authoritative guidance once that system is fielded. And then the third type of control is what I would call procedural control, which are things like geographic or temporal restrictions. Those are typically promulgated in the military, at least in the US military, in the forms of rules of engagement and special instructions. Those 3 types of controls, when put together, are designed to mitigate the worst case outcomes while still getting the desired performance parameters during employment. I would say all of us, not trying to speak for everybody, we're all strong proponents of some kind of framework like that, which is the life cycle approach that was taken in this report. And I would hope that all militaries around the world are using a similar sort of risk framework approach and a life cycle approach to understand how to mitigate or control for those risks at different points along the way. And the last thing I'll say is just to echo, in my very personal experience, as we were developing these AI models and field them, the whole point was to get user feedback constantly. And it wasn't take it or leave it, here's the system, if you don't like it, that's tough luck. It was, here's the system, we know it's not nearly good enough, you tell us what could be made better, the software company is going to fix it, we'll give it to you again and over and over and over again, what I would call a commercial software industry agile approach. That is the only way we're going to have any hope of success in the sort of AI-enabled future that we're talking about.
All right, thank you so much. Shimona, may I ask, what trade-offs would you highlight?
For sure. I think here, and I think throughout the exercise, we're seeing like multiple options emerge where we are going through the performance explainability trade-off. We're thinking of whether we need speed or whether we need enough transparency to make the right decision. So, quote-unquote right decision in as much information in as little time as possible. And I think here, especially, I was also quite surprised to see the breakdown of the choices here, because the first one that we have is basically something that we've heard being called the clever Hans example, which is basically how AI systems perceive information and categorize them and then present them to you is a very black box operation. We all know this, but especially in these kinds of scenarios, for example, so the clever Hans scenario is basically pertaining to what information the AI takes in and how does it process it. For example, if you keep showing an AI model pictures of horses, at some point it's going to tell you when you give it a random picture whether this is or this is not a horse. But you don't know what parameters it's using to define whether that is or is not a horse. Is it the ears, is it the color, is it the hair, or is it just background scenery? And if it's just background scenery, you could put any animal there and put the same background scenery and the system would still tell you that's a horse. So that's the kind of sort of thinking that goes into the first option here, where it's only telling you data that it thinks is important. There are shadow data here, which may or may not be important to the operational environment, which the user is not getting, just because the AI does not think that this is important enough information to be passed on. Which is why I think it's a riskier approach, but it's faster in the sense that if it has enough baseline training to know that these are the immediate risks that need to be handled, it may work for short term for certain purposes, but it may not work long term for many other diverse purposes for which it may be required in the future. On the other hand, the other option would be a very complex option where you have all of this data, you are constantly, as Jack said, providing information, providing feedback to it, and you are designing this kind of system for long-term purposes, for several scenarios, for diverse situations in the battlefield operational scenario. And I think in this case, it would be dependent on what you're designing the system for. Some systems would be more design them now, use them now, let's see how they work, which would perhaps then tend to option A, where we do this quick and fast, move fast, break things. And then if you are designing them more for long-term purposes, if you are designing them as baseline structures to design more complex systems on the basis of those things, then it might be option B, because you want to make sure that you're absolutely going through every single sort of ring of fire to make sure that everything works as well as it can within this particular scenario. So I think it really depends on what particular purpose this system is being designed for.
Thank you. Now I'm going to ask Nehal about legal trade-offs. But
yeah, so actually, in my view, there's no significant legal salience to this choice by itself, and I think that's probably the most important observation, that you'd want to understand the reasoning behind this choice as it relates to the concept of use, because the concept of use, which is not just this choice, but is integrated or is related to a range of other choices, which I think will affect how you'd want to characterize the legal salience of this choice, will shape your ultimate conclusion about which of these is to be preferred from a legal perspective. On its face, I think these are legally indifferent, and one can see, operationally there could be, most people seem to think A is better. One might say, well, it depends on what you're using it for. If the purpose of the UUV swarm is to get a very complete picture of the operating environment, if it's doing a lot of reconnaissance and making sure there's no obstacles in the way to other underwater operations, then actually maybe B is the better operational choice in that context. But the main thing I want to stress, and I'll hopefully will unfold this a little bit more as we go forward, is if we're, I think we become a little bit preoccupied with thinking that the legality is the feature of one particular dimension of the system. And as we go through, what I'd like to try and propose is that actually legality is a feature of the system as a whole. But you kind of evaluate it systemically until you understand the relationship between each of the components of the system. The effect of a system is the product of the interaction of its components.
Thank you. Tom, what trade-offs would you highlight?
Yeah, so I think what's really interesting about this scenario as well, and it's not listed here, was the framing in terms of how it was caveated as, quote, geopolitical tensions rise. So I think that spectre of great power competition, strategic competition, the ways in which the zeitgeist around international politics has shifted, particularly from the mid-2010s through to today, can influence and shape perceptions of necessity, right? How much trade-off are you willing to give essentially in terms of delegation to machines to in some ways manage issues beyond the technical component of these systems as a way of alleviating broader anxieties about broader shifts in international politics. And I think that emphasis on this change, both real and imagined, that we're going through in terms of the end of the unipolar moment that kind of characterized international relations after the end of the Cold War is really, really important because it can help contextualize what I think can sometimes be quite puzzling for those who, unlike us, don't work on these technologies a lot, which is essentially, why is it that despite these technologies having roots in the 1950s, has it only really been in the last 10 years that we've been having serious and meaningful conversations about what constitutes responsible uses of AI in the military domain? And I sometimes get the impression, and I of course can't ask people individually, but there is this understanding that AI in the military domain is both a cause of international instability, but for some states also a solution to managing that instability. And what worries me about that is the extent to which potentially we talk ourselves into a self-fulfilling prophecy in which we delegate more autonomy to machines to manage things that are beyond the capacity of machines, of course, to manage. And that's, of course, quite skeptical, but the roles in which our own daily experiences and interactions with technologies may have also shaped our responses to these scenarios, I think is also important. One of the things I found over the last five or so years working on these debates is, in a broad sense, you can draw a spectrum between techno-optimists, techno-pessimists, and people who are more technically agnostic, essentially. And I think the ways in which, when we've worked through this exercise, that role of geopolitical trade-off, essentially to what extent are we trying to use these technologies to manage geopolitical anxieties, the extent to which perhaps the technological juice isn't worth to squeeze. We're making a lot of assumptions here that these technologies will work and will be as strategically significant as we perceive our adversaries or competitors perceive these technologies to be, and the ways in which, when we work through these exercises, as I mentioned earlier, the role of uncertainty and how it creates a space for us all to project different understandings of the same technologies, I think it's important to note.
All right, thank you so much for highlighting these trade-offs. And now let's go back to the trade-offs that our audience provided us, the keywords. Some of them you have also mentioned, so speed, Shimona said, and context, Jack, context is everything. For those who can't see, we have efficiency, data quality, human factor, data storage, ethical considerations, human control, risk tolerance, and many others. But what I'd like to do now is perhaps ask our experts if you want to comment on one of these keywords, and if you think that one of these or several of these might be particularly important in your perspective.
I mean, just to note that there seemed to be a few people who mentioned legal compliance, and as I said, it's interesting to think about what triggers that preoccupation. My instinct is that the specific trade-off per se is not kind of by itself legally salient, but it should raise questions. It would generate, in my view, things we need to know more about before we made that choice, and to make sure that the compression of information in that way and the kind of truncation of the data is okay, right? So there's lots of questions about design and validation that have to be answered before you could conclude that that's a legal problem.
And so I guess what jumps out at me is speed is in the capital letters here. And what I'd say about speed is speed with a system that is wrong really doesn't do very much for you. So the idea of, I would say, operational effectiveness would be first, and then efficiency if I can get to efficiency. And that's the ultimate trade-off, is we're building these machines to do things that we say theoretically they can do better than humans. Back to the point about, okay, that's a fine line where that human versus machine is doing better than the other. But just to have speed by itself may or may not be what I'm looking for. I've been as guilty as anyone from the very beginning, saying the reason we're doing a lot of these systems is to give more decision-making time to humans. Let the machines go through the process data much more quicker than a human. Let the human spend more time thinking. In some context, I just don't think that's realistic, because the machines have to react fast to, say, a cyber attack, electronic warfare attack. So now we're back to risk again. Where do you allow the machines to respond as fast as machines are capable of doing? And where are you saying, let the machines process information, but make recommendations for a human to make decisions? That's the trade-off. And just speed by itself, which I'm in favor of generally, we have to be careful that effectiveness has to be first before just speed of operation.
I was going to just add, you stole my thunder a little bit, so excellent, I agree completely. I also think there's an element, so at least in the technical engineering world, I see a lot of sort of emphasis on, well, we need to build systems that are automated so that we can compensate for the lack of the human ability to do things, right? We're always sort of trying to think that we often think of the human as the one that brings all the liability to the situation, and that's not true. I liked that I saw human capacity there. I'm hoping that's in a positive sense. Humans bring value, period, full stop, right? And it's about harnessing that and augmenting that. And so to your point, speed, right? Machines make mistakes too. They just do it at machine speed. Is that really always good? Probably not so much. And so how do you kind of balance that? So, yeah.
I mean, you might not be able to see this at the back, but there's a really interesting contribution here that says, let the machines work, which I think with my war studies hat on is very interesting, right? So if you're Clausewitzian, which I imagine some of us are, you would argue that war is fundamentally a human process and political, inherently political in nature. And what would it mean for war, essentially, if we, quote, let the machines work, in terms of not just the speed at which wars were fought, but the character and its fundamental nature. So I just wanted to note that in case you couldn't see it, because I think it builds on some of the observations and encourages us to reflect on what the consequences of that in the machines work would be for not just human control, but what war is fundamentally.
All right, thank you. Thank you for this. And so we talked, human has value. So I want to get to the topic of the human and the role of the human, because this is really what is at the heart of the debate on responsible AI in the military domain. So we're going to jump to stage 4, where we had a choice between 3 options when it comes to education, training, and human system integration. So our audience chose option C, right? Well, it was pretty close, but still option C, so where the user interface is dynamic in how it presents information. So what did you make of these results? And what would be the implications of a user interface that is dynamic in how it presents information from your various perspectives?
Okay. No, happy to start this off. I think this was something that went exactly as I wanted it to go, I think, in terms of the voting for the particular options. And I think that's because whenever we speak of human-machine interaction, we always kind of focus on the machine, but not on the human that much, which is why it's super, super important to make sure that when we talk of the human, we have a good and concrete idea of what this human knows. Because without the training aspect of making sure that every human involved in the development, the operationalization, the commanding part of the system, etc., all of them understand what is the end goal in sight, what are non-negotiables, and what are negotiables. And these are things that only come after we undergo a very intense process of education, training, verification, and evaluation from a contextual point of view. Some of that has to be baseline. Some of that has to be pretty high level in terms of how it's designed and how it's then operated. And some of it has to be super contextual to the environment. For example, this is about a UUV. So we're talking about understanding how these systems operate in an environment which humans may not be particularly familiar with, for which case it should be an absolute requirement to make sure that humans are in the know about everything that happens within these systems and under the water wherever these systems are being operated. And then also something that's super important here is to make sure that that when we talk about UUVs, for example, something that came up in the earlier sort of segments here was about documentation, which I think is super important here as well, because when we talk about documentation, we not only talk about making sure that we list out every single thing that's happening, but also interaction with that documentation. How do we understand what's happening? How do we sort of concretize what's happening and codify it back into the system, and how do we then act on it? And this is a process where I think slow and steady wins the race. It's an easier line to draw from input to output, and these inputs being data sets, being algorithms, being humans putting in their own sort of operationalization here. And then to the output of what comes out at the end stage of the use of this particular system. It's a harder line to draw from output to input because it's not as straight. There's lots of complexities involved. You can't really see where systems have gone wrong. You can't really see whether it's algorithmic biases that have gotten into the way. You can't really see whether it's data sets that were flawed. So I think from the get-go is where we need to start when we need to ensure that the operational environment attunes to the kind of processing that happens within these systems and how these humans understand it. And I think that's where the education, the training, the capacity building, and the contextualization of this particular system is super, super important.
I guess what I'd say on this one is it gives me a chance to talk about one of my favorite topics. I think this idea of human systems integration will be the most important thing we work through over the next decade when we're talking about AI in the military. I would hope that over time, that as users gain justified confidence, and I'm stealing Jane Pinellas' justified confidence versus trust, which is tend to be a hardware binary, I trust or don't trust. Here, over time, as users gain more confidence in the system, I would think you end up with much more in the first column, in 3. But until they get that confidence, it's not surprising to me the results are. In theory, it is a great idea. Provide me detailed information. I can tell you at 500 miles an hour, with an enemy aircraft coming at me and the system says it's hostile, I don't have time to get detailed information. I either have some trust in there, if it's the systems I'm used to working with, or I have confidence in them because over time I have worked with those systems more and more and more, and that human-machine interaction becomes something fundamentally different than we think of it today. And I don't know what fundamentally different is, but I think it is going to be different because no longer are systems capable of humans jumping in and fixing errors. The systems are going to have to be good enough that do what systems do really well. So I would like to see that thing shift over time as users gain more comfort level with the system they're using.
Can I just ask that we go back to the bit where we had design choices, the process choice, because I think these two things are connected. I just want to go back to it for a second, if it's possible. I know we were supposed to skip over. Yeah, we had questions over Tev and also over the documentation process. Yeah. So documentation, Tev. So to me, I don't think you can evaluate ultimately any of the trade-offs about how the information is presented to the user unless you've got a very well-established justification for your design choices in the concept of operations, right? So that's one of the reasons why, in my view, choice A is the necessary choice. And choice A, it seems to me, does have legal implications, not because the law prescribes any particular design method, it doesn't, but in the current context of the technology where the validation and verification dimensions of autonomy in an underwater autonomous vehicle, which has an artificial intelligence capability which could potentially change its own steering mechanisms, but also change its object recognition, which has consequences then turned for target information. Those things together, the verification and validation dimensions of that are extremely difficult. And some of them can be validated under existing safety engineering approaches, but a lot of them can't be. And the interaction between them can't be validated at the moment. So under those conditions, actually, you're potentially designing a system which has a lot of known unknowns, a lot of latencies. So you'd want to document it very carefully. There'd be multiple trade-offs in how you validate it, what's good enough, what's safe enough, what's accurate enough. And you're also going to be designing against some basic legal requirements, right? It's an underwater vehicle. Even if it's an unmanned underwater vehicle, it's potentially a ship for the purposes of navigation laws, which means it has to operate in accordance with the requirements of safe navigation. And you have to be able to establish that. You have to be able to establish that as a legal obligation before you send it off anywhere, because otherwise it could collide with a fishing boat, it could damage underwater cables. So you have to be able to be confident that you've been able to meet those legal requirements. So the rigorous documentation, I think, is really important for that dimension of evaluation. But it's also very important for being able to have a very clear account of how you've accommodated any possible uncertainty that you've found in the process of validation and verification. And there will be quite a lot in this kind of a system, right? There's a lot of dimensions where we're not really able to solve in the way that we perhaps could for a jet fighter, the operation of the system to a relevant level of safety. That in turn feeds into another legal hazard, which is the interaction of the navigation elements with the object recognition and the identification of something as military, non-military, leading to potentially scenario 3. That's something where you're going to have to establish a framework for justified confidence according to processes and metrics that we don't entirely have at the moment, right? So all of this has to be extremely carefully documented at this stage of our development if we're going to have any justified confidence, but also if we're going to have any possibility of even being able to evaluate it lawfully, right? So to me, the dynamic information presentation is a byproduct of that.
And just a brief reminder that this was an almost equal, the results for this. So, yeah.
Yeah, so that worries me. Right.
Right.
As a lawyer, I'm worried about legal risk at this point.
So it's funny, as an engineer, one of the things we're worst at is documenting. So I can speak from experience there. And I guess my question would be, how can we do exactly what you say while still moving quickly and getting capabilities out? And so then I come back to this idea of the users being involved throughout the prototyping agile process. And we keep, exploring what reality is in real time while documenting that so that we are sort of, iterating on those things. But just one comment, I think you'd asked kind of some of the shortfalls. So I was also glad to see the results of where the team voted on UI being a bit more dynamic and a bit more customized. One of the things, I guess at least in the US, I've seen is a heavy emphasis on standardization, kind of one size fits all historically, for cost reasons, for a lot of good reasons. But where I see technology moving and what I think a real breakthrough would be is kind of this more dynamic idea where we focus on customization rather standardization. It's a bespoke solution UI to the individual user and the individual scenario. And the danger of that, of course, is that if you have a user interface that's continually changing on you, how do you know where to find the information? So that's some of the challenges there. But I do think that starts to get us away from this idea of human systems integration or human systems engineering, or pick your your H acronym, right, whatever your favorite one is, and into the human-machine teaming kind of paradigm where we have a dynamic bi-directional relationship with the system that we're using. And that really starts to open a lot of possibilities for some positive impact for AI, I think. So.
Thank you. Do you want to add something?
Just a quick one. I think I heard known unknowns earlier, and I think in terms of the great power competition dimension of this, to draw from another Donald Rumsfeld quote, you go to war with the systems that you have, not the systems that you would like to have or you may have in the future. So that dynamic element there in terms of if a major impetus for developing these systems, as some states claim, is to deter great power war, of course, that kind of way in which that dynamic may also have fed into these responses and be a factor that influences our thinking on this subject.
Can we now go to the word cloud, the last one that our audience, so the trade-offs that influenced the audience in choosing this dynamic user interface. I guess risk and transparency are the most common ones, and explainability, accountability, and again, technology maturity. Waterfall method is bad situation. So, would our experts like to comment on any of these? And perhaps the audience would like to, if anyone wants to comment on one of the keywords that they put into the Mentimeter, you're also very welcome to. We're going to open up the floor in just a bit after our experts have commented. Transparency. Anyone on that?
Well, that's interesting because it was on the last one too. And I often see transparency and explainability related to trust. And those do relate, right? Like if you not only understand what the system is showing you, but also the why behind what it is showing you as sort of a recommendation or an answer, you might trust it more, but you might not. Or there are lots of situations where we completely trust things that we have no explanation for, right, or people. So it's an interesting topic, but it's clearly at the forefront of the audience's mind, which is good.
I think I am sort of relieved that explainability seems to be something that keeps coming up again and again. And this is not just me, this is also DARPA, because they've had this project on since 2017, 2018 about explainable AI use in military applications, precisely for this purpose, because when you don't know what you're looking at, you will make decisions which might have consequences which you don't want to have. So I think the trade-offs that we come up with here are all sort of viable trade-offs in the sense that we want to have those kind of trade-offs when we design these systems, when we think about how we're going to use them. But the fact that we maintain explainability, transparency, as Lynn said, user trust at the back of our minds while we design them is always a good sign, because that means even when we choose the systems that don't necessarily have that as a priority, we're thinking of how we can include those things within next systems where these things might be developed further and integrated further. So I'm glad and relieved that explainability seems to be a recurring theme here.
I'm just going to be a little bit of a dissenter on this one. When I hear transparency and explainability, I tend to convert those into predictability and reliability. I know they're sort of two sides of the same coin, but I don't know how far we can get with transparency in sort of the heat of battle type of thing. I don't disagree with it at all. I think it's the right explainability and transparency, but I really want the system to be predictable and reliable as a user in the end game. So I'm torn by it, but I think it's just a constant discussion that's going to unfold as users get more used to these systems.
All right. Now I would like to ask whether any member of the audience would like to share their opinions on what trade-offs or if, for instance, you've changed your minds on some of your choices that you have made, especially after Nehal's comment on documentation. Anyone wants to change their opinions on that, or?
Sure, yeah. Thank you very much. My name is Joe. I work for the Swiss Ministry of Defense. Just picking up on that last point about transparency and predictability, if my system's going to be transparent so that I as a human can meaningfully control it, is not the essence of that I have to be able to predict when the next mistake is going to come. And having said that, have any of you in your experience developing these systems encountered active measures where I can actually push information to the operator that my system is moving in a space where it often makes mistakes?
Yeah, so I'll give you one example of not quite that, but this is something we were working very hard on, because the more we fielded some of these computer vision models, the more it was apparent that we needed sensors on the end game to be able to say, I'll give you the equivalent. There's something in most military systems called a master caution light. The master caution light comes on when something is wrong in the airplane. Then you have to go figure out what exactly is wrong. And there's other lights to tell you what system failed. The idea of a master caution light, when the AI model that's fielded, I'm going to use the word no, and that's maybe anthropomorphizing it, but the system says, I'm working on a boundary condition. I'm going to give you an answer, but I'm not quite sure it's the answer with the probability that you want me to have based on how you train me. So please, operator, take another look. I know that's pretty crude explanation, but I think we need more and more of that, to have sensors on these for the systems to be able to say something is not working the way you train me. And that's why people get a little bit more nervous about so-called online systems, online learning systems that are truly learning on the fly. Most of the systems I'm familiar with today are still deterministic in the sense they'll operate the way you trained them, and if all of a sudden it can't quite do something, it gives you a flag or a warning. Right now, in the early days, it was user telling us wrong, 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 relabel that, retrain, put that model update back out in the field. But I think if we're going to do this right, there has to be something to include, I think what you're getting at as well, is the possibility of adversarial attack. That somebody's coming after my system, and I just don't know exactly what they're doing, but it's not operating the way it was designed. That's the non-engineering way of saying this. I'll turn to the smarter people on the engineering.
Not smarter, but maybe an additional thought. So it's very difficult to present to a human things like confidence in an answer. So if a system says, I think, the track is this with this level of confidence, you're actually inherently biasing the human into a decision, right? Because if they have, I'm 50% sure that it's this, but it's the right answer, you don't want the human going like, no, no, no. So, and then there's this added sort of level of, well, how confident are you in your confidence values that you're displaying? And you ask the question of what are some metrics we can show? I think that's an open question. I have seen some research recently that I thought was really interesting that was on self-assessment of the AI algorithm, wherein it at least will tell the human if it has seen data like the current data or not. And so, and so I think it's similar to what you were saying,
So but I think another interesting implication of this question is what are we using the concepts like predictability and transparency to stand in for in terms of a value problem that we're trying to solve, right? So I think we use the terms as a kind of substitute for the idea, I need to know when I can or can't use this, right? So because that affects my legal and moral obligations. And so transparency could be part of a way of solving that, but it may not be, depending on what we mean by transparency. So I think probably, in my view, it's what's the fundamental problem is how have we generated interfaces and how have we understood the process of construction and operation of the system to allow us to give a kind of framework for the human to be able to interrogate the inputs and the outputs when they need to, and to flag up when they need to. I mean, that's a pretty difficult problem to solve, but that could involve explainability, it could involve transparency, it could involve a lot of things on that board. But I think we can be probably misleading ourselves if we think, well, it's all about how predictable or how probable the truth is, because actually a lot of the outputs we get are not really reflections of true statistical probability. That is a representation of an output, which is actually something else.
Yes, please.
Hello, thank you. I really enjoyed all of your contributions. I just wanted to ask, like no one really talked about like the vulnerability that is associated with any kind of system, because no system is 100% secure. So can't like external forces kind of disrupt what the AI has already learned frame it in a different way. Like earlier, we were talking about deep fakes. Can't it make a civilian vessel, for example, look like it's a military vessel to the AI that a human might be able to detect? So, no, that's wrong. And the AI might not even know that it is vulnerable at this stage. It might not even know that it's been hacked. It might not know that it's being given the wrong information. So as these systems continually evolve, because they're not static, they evolve and they evolve daily. As we were saying in the first plenary session, it's not day by day, it's almost minute by minute. So we can't have like full confidence. So confidence has to be kind of like evolving as well. So how do we deal with that?
Thank you so much for that question.
I will collect a second one,
Okay.
because I think you had one, right?
Hey, Jason from OneBrief. We build some AI tools now, and go Blue Jays, toxicologist by trade. So humans have pretty defined parameters, right? If you take too much dose of a poison, we're carbon-based, right? We're going away. Combat applications, also pretty straightforward, right? I have a tactical target, access, exploit, done. But once you apply AI to military, who determines what's best, right? Is there some way for us to program that in? Especially when you scale that, you're competing against global sentiment. So now, is it a democratic system that wins? Is it a authoritarian system that wins, right? How do you apply that at scale?
All right. Floor is open, please.
I can start with the question about vulnerability. I think that's something that we are considering when we talk about the very delicate intersection between cyber and AI. Because when we speak about, for example, data poisoning or adversarial machine learning, it always falls into this particular domain that comes within cybersecurity as well as military AI. And I think we haven't really found a neat solution to at least starting off the discussion about it yet, because we just haven't seen enough examples of it coming up or coming up in imagination. While we have had research which talks about data poisoning and adversarial machine learning in more of like a technical perspective, the conversation about this comes with a lot of political baggage as well, which even the cyber domain has not been able to resolve yet. So I think this is a conversation for us to have as we progress further within the military AI discussion outside of the perspective of lethal autonomous weapon systems, which is where most of the policy remains stuck. But that being said, I think it's definitely a very important area for us to consider, and especially when we talk about non-state armed groups and non-state groups in general, because you don't need to be armed for cyber and AI attacks.
On the second one, were you in the last plenary where Dr. Van de Hoven talked? So he's a philosopher, I believe, but talked about this idea of non-functional requirements, and we may be getting to the point where they're de facto becoming functional requirements, if not at some point de jure. I don't know. I used to be very glib and say, I don't see how you code some of these answers in, but he gave some good examples, like in the European Union, you have certain privacy requirements you must meet, period. Well, you can code that in some way. But in your bigger question, I almost think we have to spend more time working our way through some of those grand challenges of what do we mean? Whose system is a quote-unquote better system? An authoritarian system that's programmed to do this, a democratic, what is the difference? Is there a difference, or is it just, it's no longer the machines, it's still representing humans, so it still comes down to the human value system. How you code that in, I think, is something that is going to have to be worked on very intensely over the next few years. When we put out the responsible AI implementation plan in the Department of Defense, I used to say the easy part, it took 18 months, is coming up with those principles, which somebody else did, and fortunately gave them to us. Much harder pieces. How do you work with companies to start doing that? That's what he was getting at there. And so I think this is going to start playing out in pretty creative ways, but I don't have good answers. I don't have a philosophy degree. Those are the people that really want to talk about how you might get into the coding piece of this.
I have just two quick responses, one pragmatic and one legal. In response to the question about the security of the system, yes, I mean, I think it is a... I think in one way of responding to that is we have to start with relatively narrow, secure systems, right? Small systems. that can be firewalled in all sorts of ways, that can be built in ways that allow them to be air-gapped. And those systems exist, and they solve special problems, right? So, for example, a system that I'm aware of which can do, doesn't have anything to do with targeting, but it can do a lot of battlefield logistics, right? Because if you want to move a tank from one part of a territory to another, you have to know whether the roads can cope or whether the bridges will take it. Those sort of things used to take 12 or 24 hours with people sitting with maps and moving little bits of plastic around. But if you can build a relatively secure system that does that for you in different parts of the world, and it'll do it in 3 hours instead of a day. So that's feasible, and that can be put in a box and carried from one part of the world to the other. So that's that's secure against certain kinds of problems. But if you start to do that in the cloud, well, you've got a lot of problems, I suspect. So my short answer is, practically speaking, I think the security risks demand a kind of narrower approach, and I think the narrower approach will help, at least in the short term, in solving those worries. So the second question, I just want to make one observation, which is an important one, I think, in the world we live in. The international law guarantees every state, authoritarian, not authoritarian, dictatorship or democracy, the right to territorial integrity, sovereignty, political independence, and self-determination. And we learned the hard way in the context of Iraq that if you think you have a better system, and you think we're going to go in and we're going to change it because objectively we think this is a better system, doesn't always work out so well. So I think we have to hold on to some degree to those values which are in international law. They're balanced by other values, human rights, humanitarian law, but it is a calibration. These are trade-offs of principles that allow coexistence. And I think if we get to the stage where we think highly powerful, advanced systems of computation can solve problems of principle which are about coexistence, I actually think we have a big problem at that point.
Thank you so much. So we ran out of time. As you have noticed, across all of these options and all the the stages of the life cycle that we explored today, there are a lot of questions, more questions than answers, and trade-offs that arise. So I want to thank, first of all, our panelists, our experts, and also the audience for your participation in our scenario. Feel free to contact us with any questions, and don't forget to look out for the IEEE report that will come out soon. Thank you. Have a nice conference.